So, Module 2, problem number 15. Suppose a simple random sample of size n equals 200 is obtained from a population whose size is capital N equals 30,000, and whose population proportion with a specified characteristic is p equals 0.4. Complete parts A through C below. Part A, describe the sampling distribution of p hat. Choose the phrase that best describes the shape of the sampling distribution below. So you see here we have a couple of options just to start the sentence. It's either not normal or approximately normal. If we go back to our lesson, we'll remember that we need to follow at least two conditions. In this case, we need to make sure that the sample size is relatively small in comparison to the population. So here that's an n is less than or equal to 0.05 times big N. And we also need to verify that NP times 1 minus P is greater than or equal to 10. Again, that's listed in the requirements, both in the text and my lesson from Module 2. So let's go take a look at those requirements. Here I've already typed in the numbers to help us. So here we were given a sample size of 200, a population size of 30,000. So first we need to multiply 0.05 times 30,000. And there we get 1,500, which is greater than or equal to 200, which is our sample size. So we know that n is less than or equal to 0.05 times n. Next, we need to look at NP times 1 minus P. We're given P is equal to 0.4 from the problem here. So we have NP is 200 times 0.4, and then we have 1 minus P, which is 0.4. When we multiply that out in the calculator, we get 48, which is greater than or equal to 10. So that means it meets these two requirements, and we know that that means that it's approximately normal. I guess my connection is a little slow. Sorry about this. Excellent. All right. So determine the mean and the sampling distribution of p hat. Again, from our lesson this week, here I'll even show you right here, our sampling distribution of p hat, we know that the mean of p hat is p, and sigma p hat, or the standard deviation of p hat, is this under the radical, we have the square root of p times 1 minus p all divided by n. Okay, so let's go ahead and check that. Here we go. All right, so we've got the mean of p hat is p, so that's pretty easy. Let's go ahead and just put that in. That's 0.4. Fantastic. Then determine the standard deviation. That one's a little more complicated, but here we've got the square root, and then we're going to have 0.4 times 1 minus 0.4. That's our p times 1 minus p over n, and then we take the square root of all of that. And that equals 1.09545, and it tells us to round to 6 decimal places. Let's move that over so we can see them at the same time. We have 0.109545. Let's check our answer. Oops. Sorry about that. I just double checked and I realized that I divided by 20 instead of 200. So the answer should be 0.0346, or excuse me, 641. 0.034641. Sorry about that confusion. Let's try that again. Everybody makes little mistakes, right? 0.034641. Check answer. Excellent, that's better. So it is, again, very good to double check all of your calculations. What is the probability of obtaining x equals 90 or more individuals with this characteristic? Now, if you think about that, that's saying 90 divided by our sample, which is 200. So that would give us a p hat, or a p of 0.45. So it's saying, in other words, what's the probability of finding p hat greater than or equal to 0.45? Now, you could do this manually by using the lookup tables. Another option would be to do this in StatCrunch. So since some of my other solution videos show you how to do it in the lookup tables, I'm going to walk through this one in StatCrunch. So to do this, you go to Stat, Calculators, and go down to Normal, since we're dealing with a normal distribution in this case. So here, we don't have a standard normal distribution, we just have a normal distribution. That means we're going to have to change our mean and standard deviation here. So our mean that we found is right here. That's 0.4. Our standard deviation is what we found right here, and that's 0.034641. And then we're going to put in here greater than or equal to match what we're looking at here. And we want to know what's the probability it's going to be greater than or equal to 0.45. Click compute, and we get that. And it's great here because you get to see visually what we're talking about. We're not just thinking about the numbers, but here you get to see we're looking for the area under the curve to the right of that value. And this is our normal distribution curve here. All right, so let's put that in round to 4 decimal places. So that gives us 0.0745 because we round up. Check answer. Nice work. All right, click continue. Let's keep going. What is the probability of obtaining x equals 74 or fewer individuals? That tells us we're going to be looking at less than or equal to with the characteristic. That is, what is the probability that p hat is less than or equal to 0.37. So now all we have to do is switch this around. Before we were looking at greater than or equal to, now we're looking at less than or equal to. And instead of 0.45, we're looking at 0.37. Oops. Click compute, and we're given our new probability. So then the probability that p hat is going to be less than or equal to 0.37 is 0.1932. Let's check our answer. So we would say that what is the probability of 74 or less individuals with that certain characteristic? It would be 0.1932. That's how you do problem number 15 on Module 2. If you have any questions, let me know.